Okay, so let's finish off this review now. So on this one, we've been asked, the questions say find theta. They're saying find an angle, or maybe there's more than one angle. Find an angle or angles that fit in this range. So what we're going to finish with, what all these questions are going to do, is we're going to end up saying maybe draw triangles. But what the answers to the question are going to be are the angles that make those terminal rays, okay? We're going to find theta 1 and theta 2. They mostly have two angles. Sometimes you get one that only has one, but most of them have two. So bear that in mind. This is an equation. Oh, good grief. Oh, what a day. Every video's got some problem on it. This is hilarious. I think life is telling me it's time to go home. Okay, so we've been given an equation here, and it's like we're solving it. We're solving it for the value of this variable, and the variable is probably going to have two answers. This variable, theta, it really helps to use theta instead of x. That's kind of telling you it's an angle. So we're going to draw these pictures, but remember what we're trying to do. We're trying to find the angles that would give us these terminal rays. Okay, so what information have we been given? We know we've been given a cosecant that has the value. It evaluates to -√2. And what about cosecant? You know that cosecants are the ratio of lengths that are R divided. Okay. So we know our R is the square root of 2, and we know our X is 1. And one of those is negative. Which would be negative? The x. If x is -1, think about it. Okay. X is -1. That's back here. And our r is not equal 1. So it's quadrantal. We're not, our r is bigger. So we would have two triangles we could possibly draw with that x value of -1. Okay. And we know that the r is the square root of 2, just from the numerator, the same, the denominator the same. So we have to find the angles. So we are looking for, remember we want the angles? We're going to have to tell someone what that angle is and what that angle is that ends on those terminal rays. So all we can do is say, well, I must be able to tell what this reference angle is. Look at that triangle, and you know there's only two triangles we can ask you about. Is it a 30, 60, 90? Or is it a 45, 45, 90? Now, favorite question is to ask you, oh, no, it's not. We normally ask you one where it's a 1 and 2 because lots of people think that's a 45, 45, 90. I hope you realize that this one is a 45, 45, 90. Sides go 1, 1, √2 on a 45, 90. On a 30, 60, depends which one you have at the sharp end. You have the 30 here, it would go 1, and the other leg is √3, 2. Or you could have had it this way up, in which case it goes 1, √3, 2. Yeah. So this one, where we've got 1 and √2 on the hypotenuse, this is a 45, 45, 90 triangle. That's what we've been given. So our other leg must be 1. This would be -1. This angle here is 45, though. What do we want to know? We want to know these angles. Aha, we've got it in radians. It's definitely telling me we're in radians, so stop thinking 45. Our reference angle, change colors so you can see more clearly. Our reference angle is 45 degrees, but we've got to be in radians. So in radians, that's pi/4. And we know we've got two answers. We've got an answer here in quadrant 2, and we've got an answer here in quadrant 3. In quadrant 2, our angle, based on the reference angle pi/4, would be in quadrant 2, the numerator is a little bit smaller, 3 pi/4. And in quadrant 3, our angle is a bit bigger than 180 degrees. It's a bit bigger than a whole pi. So if the denominator is 4, it's a bit bigger than that times pi, 5. So this time we got two angles. This angle here was your 3 pi/4. This angle to here was your 5 pi/4. That one, and I won't do as much explanation on the future ones as that. Let's have a look at 22. And question 22, our cotangent of this angle we don't know is undefined. That doesn't mean we can't solve it. Undefined means we have got a number divided by 0. And we know we were given a cotangent, and we know that a cotangent is the ratio of x divided by y. So at this point, we know that y equals 0. I can't draw a triangle, a right triangle, where one of the legs has got 0 length. So at this point, I know it's quadrantal. That's like saying I know my reference angle is 90 degrees. I know it belongs on one of the axes. Which axis are you on if your y value is 0? Well, if your y value is 0, it's somewhere on the x-axis. Which 2 points do we have here? We have a point here and a point here. Say this point is 1, 0, and this point is the point -1, 0. See, they've both got a y value of 0. But we don't want the points, we want the angles. And we've been told our angle lies between 0 and 2 pi. Now, if we were labeling that on, go home, yes, I will go home soon, I promise I'll go home. If we were labeling the angles, you know how you label all the angles going round? You call this angle 0 or 2 pi, and this angle to get to this one over here is the angle pi. So this one's obvious, that's one of our answers. But this one, am I allowed to use both 0 and 2 pi? No, look at this. 0 is included, but 2 pi is excluded. This range was telling us my angles could be anywhere from 0 included, all the way around, including pi, all the way around a full rotation up to 2 pi, but excluding 2 pi. So my answers to this question, remember we're being asked to find values of theta, which is angles. Our angles are 0 or pi. Okay, 23. Oh, this is a superbly ugly question. No, it's not. It's not the one I thought it was. Okay, it's not that bad. Cos theta equals, now, I don't like the way that's been drawn. They've put -√3/2. I would prefer they put the negative out there. Someone's been sloppy when they type that in, because remember, the negative, you shouldn't assume it goes with the numerator. It can belong to the denominator and have the numerator be positive. Okay, it should be drawn at the front there like that. But actually, we're okay on this one because it's a cosine. X divided by r, well, that negative did belong with the numerator because we wouldn't have a negative radius. This is telling us x is -√3 and our y is not a y, our r is 2. Okay, that's what we've been told from the information. So we can draw, and they're not the same length, and neither of them are 0. If they were the same, if your hypotenuse was the same as the leg, you'd be quadrantal, same as one of your legs was 0. Okay, but we know that our x is -√3. That's like the long leg. That's the long leg of a 3690, where this side would be 1 and the radius is 2. Okay, so I've immediately, as soon as I saw this and was starting to draw it, I was thinking in my head, that angle there, my reference angle that I've just drawn there is 30 degrees. It's opposite the short side. That's a 30, 60, 90 triangle. But I've got to answer in radians. So this in radians is pi by 6. That's my reference angle. It's not my answer. But my actual angles, I'll have one angle in quadrant 2, and this one is in quadrant 3. In quadrant 2, I'm looking at this angle. Starting from here, I'm looking at that angle there. That angle there is, I know the denominator is 6 because of the reference angle. And in quadrant 2, the numerator would be 5 pi. And in quadrant 3, I'm looking at the angle that ends on this line. I'm looking at that angle. And that angle would be 7 pi by 6. So I've got 2 solutions again. The reference angle is not one of the solutions. It's just part of your work to work out what the solutions are. So that's our answer to number 23. Just a few more to go. We're almost there. Okay, on 24, and then I can go home. Wonder if I can go home. My phone tells me to go home again. Sine theta is -1. Okay, the value of a trig function is always a ratio, even if it doesn't look like a ratio. That's actually -1 divided by 1. Yeah? -1 divided by 1. And sine is a y divided by an r. Okay, it is the y that's negative because r can't be. I know y equals -1 and r equals +1. I want to know what values of theta would make that be true. Well, can I draw? We always know that r is a hypotenuse. Can I draw a triangle and it's the same length as the radius? No, I know my x is going to be 0 on this. I know this is quadruple. You cannot draw a triangle where a hypotenuse is the same length as a leg. The hypotenuse is always longer than either of the legs. So not possible. I can't draw a triangle to help with work. It's one of the ones where I draw a circle, I know the angles are quadrantal. Okay. The angles are quadrantal, and what do I know about them? I know my y is -1. That's down here. If I had a circle of radius 1, and I had a point with a y value of -1, there's only one I'm interested in this time. This one is not a solution because that would be y equals +1. So I don't want that angle there. Don't want that. 2. This time I only have one solution. Remember, angle that finishes on that ray. I have one answer, 3 pi by 2. Oopsie, pi by 2, not 3 pi by 2. Okay. It's quite unusual to only get one answer, and it only happens when you've got a quadrantal angle. Okay. It only happens when your value is -1, I think, or +1 that you've been given. It doesn't happen if it's 0 undefined. You'll get 2 answers for that. Okay, so 25, 2 more to go. 25, the secant of theta equals -2. Okay, I know that's -2 divided by 1. It's a ratio. And secant theta, that's an r divided by a x. I'm getting too tired, I'm going to make mistakes. So one of those is negative and it's not the radius. The radius must be +2 and the x must be -1. Radius is never negative. Okay, so if I'm going to draw a triangle to fit that. If x was -1, okay, I can draw 2 triangles because r is 1 as well. So I could have this triangle and I could have that triangle. And my x equals -1 and my r is 2. Okay. And I'm being asked for the angles. What these angles that would make this true? So I'm being asked for that angle there and this angle here. There's going to be 2 answers. There's going to be one answer in quadrant 2 and there's going to be a different answer in quadrant 3. Okay, 2 values for my angle. So I have to work out what those angles are. So I know that this triangle must be either a 30, 60, 90 or a 45, 45, 90. Look, the radius is twice as long as one of the legs. That's a 30, 60, 90. Okay. If it was a 45, 45, 90, that would be the square root of 2 with a leg of 1. This is a 30, 60, 90 triangle we've been given. And if this side has length 1, this side must be the long leg. The y is the long leg, the angle opposite it is the 60. Our reference angle is 60 degrees, which in radians is pi by 3. So that's what I'm going to use in both of these. My denominator is 3. If I'm in quadrant 2, I'm a bit less than a whole pi. So the numerator has to be a bit less times pi. And if I'm in quadrant 3, I'm a bit more than 180 degrees. I'm a bit bigger than pi. So it's a 4 pi by 3. Okay, these get very quick. You can do them much quicker than I'm saying them. And 26, this, and then one strange question that's not about pizza, but it is, they're often pizza questions. Says Tangent theta equals negative a ratio. Okay, -1. It's going to be -1/1. Don't think that it has to belong to the numerator. That's not true. Why is that wrong as well? Because a tangent is a y divided by an x. So either y equals -1 and x equals +1. Yes, we're going to go home in a minute. So either y is -1 and x is +1, or y equals +1 and x equals -1. One of them is negative, not the other. So how could I draw that? Oh, look, this is, oh, when the legs are the same length but pointing different directions, I'm going to be drawing 45, 45, 90 triangles. One where x goes back 1, y goes up 1, and that's 45 because that is the size of a 45, 45, 90 triangle. And the other one where the x is +1 and the y is -1. Okay. That's the square root of 2. So that's the work. What's the question asking us? Remember, we're being asked to find theta where 0 is less than equal to theta is less than 2 pi. We're being asked for angles. So I'm being asked for the size of this angle here and the size of this angle all the way around to that. So my reference angle, I know I use 45, 45 triangle. I know my reference angle, theta prime, is 45 degrees, which in radians is pi/4. And I know I've got an answer this time in quadrant 2 and quadrant 4. In quadrant 2, that angle here is 3 pi/4. And in quadrant 4, this angle here is 7 pi/4. Okay. Now let's do the last question, number 7, and then I can go home. Did I show you how to work? Did you actually see that? I have no idea if I was just talking without it showing. I the screen's didn't I? Oh, well, hope you could see that. 27. If the area, we have been told an area of a sector is 4 inches squared, units are important, with a 3-inch radius. Radius equals 2 inches. Find the angle. Find the angle. Let's call it theta, because we like calling angles theta. Okay, find the angle. Look, my mouse is in the way. It's been in the way all this time. And my battery's going low. I've got to go home, my battery's going low, everything's going to go on. Let's finish this quickly. So what do we know about area, radius, and angles? You need to know this formula. Well, theta if theta is in radians. Theta is in radians. Don't think it's in degrees. You have to turn it into radians. It is in radians. What can we replace? We know that area is 4 pi. So I can replace A with 4 pi equals 1/2. I know that radius is 2. So this is going to be 2 squared times theta. So just solve this. 4 pi equals 1/2 times 4 times theta. Half of 4 is 2, so I've got 4 pi equals 2 theta. So divide by 2, 2 pi equals theta. Theta is 2 pi. Oh. Find the angle. Well, that's the whole circle. Okay, the angle was the whole way around a circle. What a strange question. But that's what it was. That's the answer. Unless I've done something crazy silly. That's a strange answer to give someone. Oh well, but it is, that's what it is. Goodbye guys, hope that was helpful.